All right. Good morning, everyone. My name is Eric Selge, and this is VFP and AI. That's wishful thinking. A little bit about me. I've been a Fox Pro developer since version 1.21a. Don't do a lot of Fox Pro developing these days, sadly. I do a lot of IT security, cybersecurity. You've seen a couple of those sessions go by here for the federal government. I am still doing MadFox, the Fox Pro user group here in Madison, Wisconsin. Been doing that since 1995 when Fox Pro 3 was released, and we realized that we're going to need a lot more help from other people. And we are still going. We still meet every month. In fact, here's a photograph of us last month at a Brewers game. We all got together and grilled out there, tailgated. I want to point out this guy here. That's Peter Diot, who you heard about in Jim Nelson's session. He's uh, he's still around. He's in Milwaukee. He's retired now from Harley Davidson, but I think I can say he is grateful that Jim and Matt continued his work on Go Fish. So well done, guys. All right, today we are going to look at the big picture overview of what is artificial intelligence. I had an idea of showing you something very specific about a specific product, and we'll get to that in a little bit. But I realized that I needed to sort of step back and just get my terminology down and some of the foundational concepts down first. So we're going to start by just talking about what artificial intelligence kind of is. It is a big picture. Then we'll drill down into how AI can help you as a developer. And then we'll look at specific ways to integrate AI into Visual Fox Pro. And lastly, we'll look at some issues that rise with artificial intelligence. So we do have a lot to cover. So let's dive in. Go here and shut my camera off. All right. So let's start with what is artificial intelligence? Is there any technology that is as hyped right now as artificial intelligence? I mean, over the past few decades, it's evolved from a niche field of study into a transformative force that is reshaping our world in real profound ways. It's exploded, especially in the last year or two. And now it's the cornerstone of a lot of modern technology, driving advancements in various sectors such as healthcare, financial, transportation, entertainment, enhancing medical diagnostics, automating financial transactions, powering self-driving cars. Think about how quick things are changing. It's crazy. Personalizing your online experiences. AI's applications are vast and varied. And so when I do this talk today, I want you to think about how you can use some of these concepts in your applications for your industry. One of the most significant aspects of AI's growth is its ability to process and analyze massive amounts of data, providing insights that were previously unimaginable. And this capability is improving efficiencies and productivity and enabling us to tackle some of the most pressing challenges of our times. And it's becoming integrated into our daily lives, whether through virtual assistants like Siri and Alexa, recommending algorithms or on streaming platforms, smart home devices. But with AI power comes great responsibility. And as we continue to harness the potential, it's crucial to address those ethical considerations and ensure that its development and deployments are guided by principles of fairness, transparency, and accountability. So in this presentation, we will explore the remarkable journey of AI a little bit, its current impact on various industries, and future possibilities that it holds. And we'll also discuss the ethical implications and the steps we can take to foster responsible AI development. So what is AI? AI is not magic. In his 1962 book, Isaac Arthur C. Clarke formulated his three laws, and the third law, which is the best known, is most widely cited, is any sufficiently advanced technology is indistinguishable from magic. And I got to tell you, AI does seem like magic sometimes. It really does. And if anybody remembers the other two laws from Arthur C. Clarke, go ahead and throw it in the chat. But nobody else remembers them usually, except for this one right here. It is not magic. So if it's not magic, what is AI? Simply put, AI is software, period. And as software, this is from Dino Esposito, the modern day Arthur C. Clarke. I don't know if that's true. So it gets numbers, it returns numbers. It's a black box that returns a number. With that number, that it is the same other problems that we still face today in software development. And I think it's really important to keep this in mind. The simple concept, AI is not magic. It is something that is knowable, that we can figure out and we can use just like any other piece of software. Now, AI is a big topic, a big general phrase. So let's start getting some terminology down. The first one is there's three types of AI. The first one's called narrow AI, and this is where we are today. This is we're right now on the precipice of something that's going to transform almost everything. But narrow AI, the first kind of AI is also known as weak AI, refers to artificial intelligence that is specialized in performing a single task or a limited set of tasks. It cannot generalize its knowledge or to other areas or tasks outside of its designated function. And then within narrow AI are various other, sorry, there are various types of narrow AI based on the tasks that they are designed to perform. And you can probably rattle off a lot of these too, right? There are natural language processors like the Siri and Alexa, and I got to be careful what I say because my phone's going to perk up here. There's computer vision AI, right, that can recognize objects. There's recommendation systems like Netflix telling you what show you're probably going to like next based on your history of watching things. Your Spotify playlist example, for example, your speech recognition's AI, self-driving car AIs, image facial recognition AIs. These are all types of narrow AIs. Something in your applications for your business might be what's called an expert system, which uses a predefined set of rules um, to make decisions in specific fields like medical diagnoses or financial systems or legal decisions. And that's something in the courts that we're seeing a lot more of right now. And Westlaw and Lexis are tools that our lawyers are using to evaluate opinions and look for, discrepancies and things like that. Judges as well. There's AI for fraud detection. If you've ever gotten a credit card alert, right? How does it know that that's fraudulent? Well, it's all pattern matching, right? Yeah, so each type of narrow AI is highly efficient at its task, but cannot perform outside of its own domain. Now, within narrow AI, there's actually subtypes of AI as well. The first one, which we've been familiar with for a few years now, is cognitive AI. And Microsoft has been big on this with its cognitive services for Azure. This is how computers can recognize items in photographs, songs based on their melody or their faces. Um, Whether it can look at a picture and decide if it's a hot dog or not a hot dog. And if anybody gets that example, you're my kind of person because I love that Silicon Valley show. But how does it know? How does it know these things? Well, we've been training this kind of AI for years and years and years. I think every product that Google has ever released was ultimately designed to train its train its models so that it can learn from what pictures, what's in a picture, or Gmail was nothing more than a way to train it on how people use language. Maps is nothing more than learning the driving patterns. It's everything that Google's ever done has ultimately been to train its AI models. Another type of AI, though, is what's called generative AI, and this is what's getting all the hype these days. So cognitive AI recognizes things. Generative AI is a type of narrow AI designed to create original content, such as text, images, audio, video, code, which we'll see in a little bit, in response to prompts. It uses generative models that learn patterns and structures from large data sets, like we just talked about from Google, to produce new data with similar characteristics. So some key characteristics of generative AI is content creation, like we just mentioned, creating all those works. Generative AI models are trained on extensive data sets, allowing them to understand and replicate complex patterns. And examples of generative AI are things like, GPT-4, image creation like DALL-E, deepfake technology, text generation image generation, music and audio. It can do it all. It's powerful within its domain, but does not possess the broad, adaptable, intelligent characteristics of general AI, which is another is from narrow AI. The next step up is going to be what's called general AI. Uh, about those large data sets. So LLMs are used that's the training model that is used for generating the text versus audio or graphics. Audio and graphics does not use LLMs. Large language models are a type of artificial intelligence designed to understand and generate human language. Imagine them as like super advanced text prediction systems. They're trained using vast amounts of text data, millions of books, websites, everything, every comment you've ever posted on the internet, every blog you've ever posted, anybody's ever posted. It's been slurped up and training this data. And they looks at it and learns to recognize the patterns and how language is used using a process called machine learning. The model is fed enormous data sets and books, websites, like I mentioned, social media posts. And then during the training, the model learns to predict what word or sentence should come next based on the word it's already seen. It picks up grammar, sentence structure, cultural references. And at the heart of LLMs are what's called neural networks, which is something I actually did back in college, back in the 80s. And they're now being utilized for these LLMs. It's inspired by how the human brain works. There's different layers. And I should mention, by the way, this is a really shallow overview of artificial intelligence. Any one of these topics is an entire master's degree, right? So I'm sorry, I'm not going to go too deep into any of this. I just want to get our foundational knowledge down here. One of the key strengths of LLMs is that they understand context. So example, if you type, I went to the bank, the model can figure out whether you meant a river bank or a financial bank based on the words around it. That's the context, and it gets it. It looks at the entire sentence and even previous sentences to figure out what you're talking about. And not just previous sentences. Now we're finding out that it can go back to the beginning of its memory and use everything it's ever remembered and learned to get that context. And then when you give a model a prompt, like asking it a question, it generates text based on what it's learned. And it doesn't think or know things like a human, but it's really good at sounding like it does because it's learned the patterns of language so well. Here's a couple of those large language models. The one you've probably heard of is GPT-4. But that's just one of many different kinds of models. And the models are all slightly optimized in different ways. And have different numbers of parameters. Essentially, the more parameters you have, the more that the model can adjust during the training to get better at language tasks. So the more complex it can be. And also, the more power it takes, and the more less speed it probably has as well. But those are actually issues that they're working on. So you may say, okay, so if there's large language, hopefully you don't say it like that. You may say, if there's large language models, does that imply the existence of small language models? And yes, it does. There are small language models as well. They have fewer parameters. They're scaled down versions designed to understand, interpret, and generate human language, but require less power and data to operate effectively. They have, like I say, fewer parameters compared to large language models, thousands to a few million parameters compared to how much did this have? Billions that the large language models have. They're more efficient, optimized for efficiency, and they're usually designed for specific use cases. They're trained on smaller, more specific data sets. In fact, it might be your data set that it's trained on, and we'll get to that in just a little bit. Some specific examples of these, Microsoft has a product called Phi. I think it's pronounced Phi. That is a small language model as in contrast to their large language model. So particularly useful for applications that require lower latency, reduced computational costs, enhanced privacy, and because they can often run locally on devices. And we'll get to that in just one second. Before I get, I really want to talk about vector databases as well, because when I started hearing about artificial intelligence, I wanted to know what was going on under the hood. And as a database guy, I was curious, like how are we storing 45 billion parameters? I didn't know how any of this worked, so I started going down this road of learning about vector databases. And to understand vector databases, you first have to understand what vector. I think we should probably all know that. But in math and physics, a vector is a quantity that has magnitude and direction, and it can be broken down into components. For example, in a two-dimensional space, a vector has an x and a y vertical component. In data science and machine learning, a vector is an ordered list or sequence of numbers that represents data, and I'll show you this in just a second. It can represent any type of data, including unstructured data or data without a predefined data model or schema. And that's, for us, that's kind of hard to put our heads around because we're relational database people, right? We've got tables and rows and columns, but a vector doesn't need any of that. It could be texts, text to image, audio, video. Vectors can store any kind of representation like that. It's usually in the database itself, it's represented as an array or list of numbers where each number in the list represents a specific feature or attribute of that data. So for example, imagine you have a large collection of cat photos. Each image is a piece of unstructured data, right? It's a string of bits. But you can represent each image as a vector by extracting such features out of that, such as the average color, the color histogram, the texture histogram, the presence or absence of features like ears or whiskers, and then the embedding, which we'll talk a little bit more about embedding in a second, is the process of converting those features and other data into numbers where each data point is represented by a vector in high dimensional space. And that high dimensional thing is kind of the key because it's hard for us to imagine things outside of 3 dimensions, but vector databases can go into multiple dimensions. So that's a vector. And a vector database or a vector search database or vector search similarity engine stores, retrieves, and searches for vectors. And instead of rows and columns, like we're talking about, typical of relational databases, vector databases represent data as points in multi-dimensional space. And they're ideal for applications that require a rapid and accurate matching of database data based on similar rather than exact values. And I was thinking about this while Jim Nelson was talking about Go fish. If we could just import all the code in your application into a vector database, we could make Go fish quantumly faster, right? Because everything would be based on similarity rather than exact value. So sorry, Jim, there's your next task. One person says, imagine a vector database as a vast warehouse, and the artificial intelligence is the skilled warehouse manager. And in this warehouse, every item is stored in which is the data would be the item, is stored in a box, which is the vector, organized neatly on the shelves in multi-dimensional space. It's hard for me to wrap my head around that, honestly. But hopefully you have a better understanding now of kind of how that data is stored underneath the covers. I'll pause for questions in just a second. Let me get through a couple more slides here. So transformation is the process of converting that data from one format to another. I mentioned that in a second ago. To situate those vectors in that multi-dimensional vector space. One of the most striking features of this spatial arrangement, you can see how far away, for example, in this picture, cats are from apples. And again, this is all we can do is visualize 3-dimensional space, but that's the best I can do. It's really multi-dimensional. One of the most striking features of this spatial arrangement is that data points with similar attributes naturally gravitate towards each other, forming clusters. So vector embeddings are not just numerical translations, they actually encapsulate deeper semantic essence and the nuance of the original data, and that makes them invaluable for a range of AI applications. So, and underneath the covers, central to the functionality of the vector database is that principle of embedding. So this is actually what it looks like in the database itself. You can see that there. I actually had a vendor show me at a conference I was at fairly recently. He opened up a vector database, and I looked, and there was what we would call a column that was very large, and it held a ton of these numbers, right, like this. Hopefully my mouse cursor is hovering over the embeddings right now. So while the vector itself is fundamentally an ordered set of numbers, an embedding is transformed that number. An embedding transforms it into a representation of various data types. Well, that doesn't make any sense. I don't know what I'm saying there. Sorry about that. But let's talk about this a little bit, because this again takes me back to the Go Fish presentation a little bit. Querying this vector database is, as you can imagine, different than querying a conventional database. There's no like, seek command for this, because instead of hunting for precise matches between identical vectors, which probably don't exist, a vector database uses similarity search to identify vectors that reside in close proximity to the given query vector within that multidimensional space. And this approach, of course, more closely aligns with the inherent nature of data, unstructured data, and also gives you speed and efficiency that traditional search cannot match. And I had heard somewhere that under the covers, this index, which is really, and this is something to think about as well. We are when we're prompting AI, we are not searching here in the embeddings itself. We're not looking in the vectors. We're searching in the index, just like an index table in FoxPro. Not just like, but I did hear that under the covers, these indexes are use a type of bitmapped index, and that made me think, isn't that what Microsoft bought FoxPro for, because of Rushmore technology, which used bitmapped indexes? I wonder if there's a similarity there. Maybe somebody can put that in the chat if they know that there's a similarity. So words, sentences, entire documents can be transformed into these vectors and then that capture their essence. There's a standard actually for this embedding method called word to vec, and words with similar meanings are represented by vectors that are close in multidimensional space. And one example that I had that kind of brought it home to me is if I put in king minus man plus woman, what should I get? And the answer is queen. And it does that because adding the vectors associated with the words king and woman and subtracting man is equal or close to the vector associated with queen. So mathematically, if you can picture what's going on there, where it's subtracting taking a king vector, subtracting the man vector out of that, adding the woman vector, you get a vector that looks awfully close to the vector for queen. I should have had a picture for that. All right, I'm going to take questions right now, but I do want to mention we've only talked about narrow AI at this point. I briefly mentioned general AI. That's the next step in this process. It's not here yet. We're still in the precipice of all of artificial intelligence, and we're still in narrow AI. But general AI will have the ability to understand, learn, and perform any intellectual task that a human can. It can think and reason like a human, can transfer learning across different tasks. Now, and this doesn't exist yet, but if you've ever watched Iron Man, for example, when Iron Man is flying around talking to Jarvis, Jarvis is an example of general AI. I put a picture here in the slide of my favorite example of general AI. If anybody know what movie that's from, my favorite movie of all time, put that in the chat. After general AI becomes the future, the ultimate goal, and I actually heard this mentioned by the Sam Altman this week, is what's coming is super intelligent AI, which is AI that surpasses human intelligence and abilities. It can perform any intellectual task better than humans, and creative decision-making tasks, social intelligence. Of course, this is all very theoretical at this stage, but it's in the movies you see it. It's the AI that in the future that where it surpasses human abilities and outperforms humans. All right, that was a lot. Sorry to throw all that at you, but I needed to get this foundation down so that we all have an understanding of what AI is, what it's comprised of, and the fact that it's, most importantly, just software. And under the hood, it's all a database, just like we're used to. So, Rick, how are we doing for questions? I can imagine that there might be a few.
Your imagination is better than the questions, so we don't have any at this time.
I may have lost everybody, and I apologize. That was a lot. Um, but if you think of any questions, please throw them in. Did anybody put the name of the movie in that has TARS in it?
No.
I was going to buy a beer for whoever put the name of that movie in there.
Not yet.
Okay. Well, if somebody can think of it, let me know. All right. Well, now let's bring this on home. How can you, as a developer, use AI? And hopefully some of you guys are already doing this. First is AI assisted coding. So this is when you're in your IDE and you're typing along and you can, the IntelliSense, if you will, is on steroids and it says, oh, I see you're trying to, create a loop here. Let me just hash that out for you and finish it up for you. And then it creates a perfect piece of code for you. That is already in Visual Studio. It's in even in VS Code, the free version, and a lot of other IDEs. It is not, unfortunately, integrated into the Visual Fox Pro IDE, but that would make a fantastic VFPX project if somebody wants to hop on that. But for a Fox Pro developer, then what can we do with AI? Well, it's funny. AIs actually do know about Fox Pro. And of course, where do they get that knowledge? Like I mentioned before, they've been slurping up everything about everything that's been put on the internet. And some people have been generous enough to put entire books about Fox Pro up on the internet for it to slurp. It probably found the help files. It looks in every forum that we are contributing to. Probably looks at our white papers that we're doing for this conference, and reads it all and understands it maybe. And let's do a demo of this here quick. So let's look at specifically ChatGPT. What does ChatGPT know about um, AI? Oh, let's go back to this for just one second because I'm going to tell you. I'm going to do the demo in a second, but I got an email from a guy who, and this is verbatim the email I got a couple months ago. He says, "Hey, I got this Fox Pro app that uses CodeMine. I really want to convert this app to 64-bit VFPA, but it's got this CodeMine, this 32-bit dependency on CodeMine.fll. FLL is being 32-bit, right? VFPA can't use 32-bit, so I'm trying to convert this FLL, but I use my usual tools, but it doesn't really recognize. So what are my options?" And when I got this email, I thought about it for a little bit, and I gave him what I thought were some fairly decent solutions, which is, maybe put a wrapper around this that in 64-bit that you can make calls to, um, and then that way this can stay as a 32-bit FLL, but you'll have a 64-bit wrapper around it. Maybe WW, a Westwind wrapper or something like that, so they can be, if as long as they're not user interface, um, as long as it's not for the user interface, that should work fine. I asked about Refox or some other solutions to decompile the FLL, and I don't remember what else I said, but I gave it like 15 minutes worth of thought, and then I thought after I started doing this presentation, well, I wonder if ChatGPT would know anything about that, right? So I asked ChatGPT, and let me show you the exact response it gave because it was strikingly similar to what I had. So I put that exact quote into ChatGPT. Hopefully, you can all see this okay. That exact question into ChatGPT, and it said, I thought I was going to tell you, I was shocked by how deeply it understood the question and gave me thoughtful answers. It says converting it can be challenging because Fox Pro uses FLLs are essentially DLLs that Fox Pro uses to extend functionality, but they are written in C or C++ and compiled as 32-bit. So here's a few potential approaches. Decompile it, and it gave me a couple of options. Recompile the FLL by accessing the source code and rewriting it. Use compatibility layers. Investigate alternative libraries or solutions, or convert that FLL to 64-bit, which I don't know. I don't think the answers were particularly fantastic. But the general idea that it actually knew what an FLL was, what FoxPro was, what recompiling was, and concepts on how to get around this shortcoming, well, I was pretty impressed. So if it knows this much, if ChatGPT knows this much about VFP, you could put any question in here probably and have it give you a decent answer. And if anybody has, well, it's a question they could want me to ask it. But hopefully, you guys are already using ChatGPT to ask your questions about FoxPro. One of the things I don't like about this, though, is that it could be the death of our forums, right? Who needs Foxite when this ChatGPT has already slurped up all the answers in Foxite and can just recite an answer to you? Now, of course, it's up to us to look at these answers to make sure that they are correct. And I can't emphasize that enough, and I'm going to emphasize it again in just a minute. But it is giving answers. All right. Any questions at this point, Rick? Because I'm going to get into a different shift gears here in a second.
No, but Joel did come up with Interstellar as the movie.
Well done, Joel. That is correct. That is my favorite movie by far. All right. All right. So when I first proposed this session, I had been alerted to a product called Wishful Search, and that's why the name of this session is VFP and AI. That's wishful thinking, because I was going to demonstrate how to use this specific product called Wishful Search to allow you as a FoxPro developer to upload your data, get it embedded and transformed into a vector database. And this is why I had to backtrack and talk about what all those things were, because I didn't know what any of those things meant at the time. And it became a different direction for me at that point, because I figured if I didn't know what any of that stuff meant, there's probably a decent chance that some of you might not as well. And so I actually scrapped this idea of just talking about Wishful Search, which is a project that is still out there on GitHub. It's an open source um, AI product that doesn't seem to be supported anymore either. So that's another reason that I'm glad I didn't just go with this idea in the end. And also, you don't really need this particular product. I mentioned that there are these small language models, which is what this would have been. But even small language models aren't something that you really want to run on your laptop unless you have a very, 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 very beefy laptop or PC. Um, there's unless it requires the minimum 16 gigabytes of RAM and then a ton of hard drive space to store all those parameters and such. So I decided to go in a different direction to show some of this AI concepts. Instead of downloading this stuff on your local PC, there's all kinds of AI sandboxes out in the world that you can play with. And this is a superior solution because A, they're always up to date. You don't have to keep them maintained. They have whatever RAM you want. You can pay whatever RAM you can afford, you can pay for. It'll allow you to try the latest and greatest LLMs and SLMs. You can compare and contrast different models. You don't have to download all the models to your own PC. You can just use theirs, and with a flip of a switch, and I'll show you that in a second, you can see which models are more effective for you. So let's see here. Here's a few examples of some of the AI sandboxes that are available out there. And if any of you are using any of these, go ahead and throw that in the chat. Let us know what you're using. I am going to narrow it down to focusing on just one, though, right now, which is Azure AI Studio, for a couple of reasons. One is that, as you may know about me, I am very cheap, and Azure AI Studio gives me $200 worth of credits to play with. And I looked at it this morning, and even with all of the playing around that I've done setting up this presentation, I think I've used 21 cents of time out of my $200. So I like that a lot. I can afford that. And also, it's Microsoft, of course, and Microsoft's products never let us down. So, got to go with them, right? Pause for laughter. Excellent. Okay. Um, and it also has an SDK and an APIs that we can play with, and of course, we're going to want to use those as developers. So, oh, I kind of got ahead of myself there. Sorry about that. Here's the free account that you can get with Azure. All right. So, I think I got ahead of myself there. All right, let's take a look at Azure AI, and let's ask. Oh, gotta figure out what I'm actually doing here. Let's ask ChatGPT how we can as Visual Fox Pro developers. Let's see if ChatGPT knows enough about Fox Pro and Azure AI to tell us how we as a developer can integrate the two. Okay, so this is the prompt I used in ChatGPT. I'm a developer using Visual Fox Pro. Write me a function that will interact my application to Azure AI Studio. And it came back and said, oh, yeah, to interact with Azure AI Studio, you got to go set it up. And you're going to get your API key. And then you're going to do a setup, an HTTP request in Visual Fox Pro. And then you're going to handle the response, which is kind of what I expected it to say, right? And then it actually gave me some code. It gave me this code. I don't know if you can see that. Hopefully you can see that okay. But it looks like straightforward, uh, creating an MSXML2 object, and then sending the request. It's got some kind of funky thing here called uh, uh, authorization. Let's see what else is in here. Oh, something called max tokens. So max tokens means, okay, so this is the way that these sandboxes will bill you. It's not by the word, it's by the token. And tokens are like the smallest units of data used by the LLM to process or generate text. So imagine each word, punctuation mark, even part of a word in a sentence gets broken down into these individual pieces called tokens. So it's not a one-to-one correlation with how many words you're using or how many words it responds with, but it's sort of analogous to that. And then there's something here called a temperature, which is a weird word, a weird name for it. But what a temperature is it goes from 0 to 1, and a higher temperature, the closer you are to 1, results in a lower, what they call probability, which means it's going to be more creative with its output. And a lower temperature will result in higher probability, more predictable outputs. So that's a parameter you want to play around with, depending on what your use case is to um, to get the results that you're looking for. So essentially, yeah, I'm putting together a JSON string here, which is the prompt, uh, the tokens, and the temperature, and sending that off with my API key off to the URL that I opened, and I get a response back. The response is in JSON. If I don't get a response back, I get an error back, and I just show that error. Is this right? This is what ChatGPT came up with for code. Is it right? Well, it's up to us as human beings. Then I can't emphasize this enough. Anything that AI sends back to you is up to you to verify as a human being. So is it correct? Well, maybe. Well, we're going to try in just 1 second. I do want to show one more screen though, because after it gave me that code, it actually gave me this explanation. It actually told me, here's what you're doing here, and here's what I mean when I do different things. I thought that was pretty nice. It actually told me the requirements as well. You're going to need this on your environment, and you have to have it configured with an API key. So I went out to Azure AI Studio. I set up a new project. I got my API keys. I put them in an H file. I included the H file, and I ran it. And did it work? Well, let's go to Fox Pro here and see. The code as it was written did not work for a couple of reasons. One is that the prompt, it had a prompt, and that's no longer supported. It's a whole different look now, as far as that JSON string goes. So that had to be updated. And of course, I had to ask ChatGPT how to update it. And then the URL wasn't quite right as well. But other than that, if you look at this code, which does work, and I'll show you that in just 1 second. Of course, I embellished it a little bit by just doing some parameter checking here. And that's one thing we're going to talk in the end here about prompt injection and such like that. You definitely want to validate your parameters to make sure that nothing slips by you. For example, I probably shouldn't just accept this prompt and send it along. I should make sure that it's not doing certain things before I send it along, like have any, extra code in it or something like that. But overall, this code looks, kind of similar to what it gave me as an example. Um, I had to tweak a few things to get it to work because I got a few errors, but then it worked. So I was pleasantly surprised. Let's try it out here, shall we? So if I do that and I just ask it a question like, when was VFP last released? It comes back with this JSON file, which I have to parse, right? And this isn't a session in parsing JSON, so I didn't get into that, but hopefully you can see that okay. Let me just zoom into that just a little bit here. How do I scroll over? You can't quite see it. Sorry about that. Oh, maybe if I do here, let me put the cursor. Well, I don't know if you can see this, but it says the content of the results was Visual Fox Pro was last released in Microsoft by Microsoft in 2007. Is that correct? I don't know. That's what it said it was. So it's up to me now to evaluate those results. But overall, that command that it gave me from ChatGPT is something that worked, which is kind of surprising. So ChatGPT can totally help write code that works to call to Azure AI. So this call doesn't go to ChatGPT. This one's going to my project in Azure. Let's look at that quick. This is what they call the chat playground in Azure AI Studio. This is the project that I set up, and under the covers, this is the API key that I used to ask this question. And this is hopefully you can see this okay. One thing I did, you can give it system prompts. So I said, you are an AI assistant that helps people find information. Your main language is Visual Fox Pro. And just based on that, I said to it, how do I get the current date and time? I didn't tell it what language I wanted. I just said, how do I get the current date and time? It says to get the current date and time in Visual Fox Pro, because it understands that, right? That context that I gave it, it has that memory of the prompt, of the system prompt. You can use the date and time functions. And it gives me some example code, and it actually gives me a little copy thing here too. And a little extra as well. So that's pretty cool. We can ask it anything else too. For example, I don't know, what is a good open source repository? I have no idea what this is going to say to get code. Let's hope it comes back with VFPX here, but let's see. Oh, this is a problem I've been having with the interactive prompt here, is this rate limit is exceeded. Let's take this code though and go over to my Fox Pro. This is calling the same project, so let's see what this comes back with. Oh, I think this one is not calling the one that does Visual Fox Pro. So let me say for Visual Fox Pro. Oh, look at that. One good open source repository for Visual Fox Pro is GitHub, and there are many repositories on GitHub that contains code for Visual Fox Pro, and you can search for them. Some popular repositories include VFPX, which is a collection of open source tools and utilities for Visual Fox Pro. Hey, very cool. I don't love this, so I wrapped all of this into a user interface, which does essentially the same thing, but it lets me tweak my temperature and my max tokens as well. So let's do that again. What is a good open source repository to get code for Visual Fox Pro? And that gives me, of course, the same results back in this little thing here. And if this were a class on parsing JSON, I would have done that and just pulled out the content here, which is trivial to do. So that's pretty cool. Any questions at this point, Rick?
Zero at this time.
I'm going to need you guys to step it up out there because I'm actually talking into a void and I don't even know without these questions that anybody's listening. Are we recording this for YouTube?
Yes, we are.
Okay, great. Um, okay. So that's pretty cool. And it's actually fairly trivial to integrate AI with our Visual Fox Pro application, but that doesn't do us a ton of good. At this point, we've got a glorified help file, right? We want as developers to integrate our data into AI as well. And that is where we get into something called RAG. And this is surprisingly not named after Kevin Ragsdale. RAG is an acronym or initialism, stands for retrieval augmented generation. And that augmented is the key because we want to augment the results with our own data, whether it comes from our unstructured data like PDFs or Word documents, or our structured data, which may include, it definitely includes JSON. And that's where that Wishful Search project was going for. It converts your data to JSON and then uses that to do this retrieval augmented generation. And that's going to be a step that you're probably going to have to do with most LLMs, although I am told that it also understands, some of them also understand .SQL files, which is if you go to your SQL database and export your data. And of course, you'd only want to export, you got to be careful about what you export. You don't want to export all your data, but just the stuff you want to use in your searching. It can generate a text file, which is a .SQL file. And some of these LLMs can use that format as well in this retrieval augmented generation. So retrieval augmented generation is a design pattern that combines the pre-trained large language model like ChatGPT or whichever model we're using with an external data retrieval system to generate an enhanced response incorporating that new data outside of its original training data. So adding an informational retrieval system to your application enables you to chat with your documents. And when they say documents, I think they mean database, right? For us, it would be database. Generating more captivating content that's more applicable and really access the power of LLMs for your data. You have more control over the data used by LLMs as it formulates a response as well with retrieval augmented generation, because rather than, here's an alternative, right? You could just upload your database to OpenAI and let them use your data. But of course, that would be very, very bad because then they're not just using your data for your results, but for everybody's results. And you're bound to get some data leakage and some privacy issues as well there. So you don't want to do that. You want to keep your data private to you, but still use the power of the general LLM. And that's where this RAG comes in. So if you use, let me go back to open Azure here as well. And one of the things that you can see here is the ability to add components to here. and I added one called fake data. I actually used the same Mockaroo application that Tamar mentioned yesterday to generate just a bunch of 1,000 rows of garbage, mocked pretend data. And I uploaded that as a CSV file, which is structured. It's not unstructured, but I uploaded that into my model here. And hypothetically, now I can ask my model, if I go back to the playground, oops, go back to chat. I can ask my model questions about my data. However, every time I do that, I keep running into a limit. So let me see. I'll just try it again, but it's probably going to, let's see. It's probably going to give me the rate. So what I could say is, for example, create a table of my users broken down by country and with a count from each country. Yeah, this is what happens. Oh, this is different actually. Field required. Oh, that's better. Every other time I've been getting I'm sorry, Dave, I can't do that type of error message, which really pisses me off because it's so meta. Okay, well, maybe I need to play around with this more, but that's the idea where you can have your data uploaded to it or a pointer to your data. If I go back to data and I say add data, what do I say? Add data. Somewhere there's a way to say add data. Oh, I missed it here somewhere. Where's the versions? Hold on, let me go back to here. Nope, those are different models I can choose from. Oh, here's my playground. Sorry, I got to go back to here. Nope, here. Oh boy, now I've lost where it is where I can add my data. But I'll tell you this: you add your data, and then it actually goes through that transformation process and the embedding process into a vector database behind the scenes here, and creates an index. And just gave it a funny name. And this is the index that you're going to use when you're actually searching your data. What happens if I click on that? Oh, this is interesting. I've never done this. This is details about my index. Is it going to show me the actual? I'd love it to show me the actual vectors. Hmm. And again, there's a whole at least a pre-con about just that part of what we're doing here. But they say the teacher is only one day ahead of the student, and that's exactly where I am at this right now. All right. So that's retrieval augmented generation. And you can add your data into your project and get results from your data, hypothetically. Um, yeah. Look, I took a screenshot of where you add your data, but somehow I couldn't find that. Oh, I'll stop looking right now. Okay. All right, well, here's a break. That's all I'm going to show for code. In the end, I will give you a QR code. You can download the code that I just showed you and play around with it yourself if you set up an Azure AI Studio. Any questions, Rick?
None at this time.
Excellent. I can only assume that means I'm doing an amazing job of explaining everything. That's the only possible explanation I can think of.
It is.
All right. So we got what about 20 minutes left? So Tamar wanted me, especially specifically said, "Hey, you talk about AI, but I definitely want you to talk about, you know, the guidelines, the boundaries, the pitfalls, the risks of AI as well." So let's do that. And for me, as a security guy these days, this is kind of interesting as well for me. So let's start with security risks, because what kind of IT security guy would I be if I didn't start by mentioning the risks? Um, there are risks, of course, and there are so many risks that it's been formalized now by OWASP, which is the agency that also points out risks, for example, in websites and other coding issues. They've generated their own top 10 security risks now for artificial intelligence. And number one, which is something you hear about a ton, and is actually kind of a lot of fun, is prompt injection, which is where you try to fool the AI into giving up information that it really wasn't meant to give up. Um, and there's a great there's a great website out there called I'm not sure what it's called, but if you just Google Gandalf and prompt injection, it's a great exercise in doing prompt injection to try to extract information, a password in its case. You're trying to get a password out of this system, and it's been programmed not to give you the password, and it gets very each level gets a little more difficult. But it was fun to get through all the levels and figure out all the different ways you can skirt around the guide rails that were put up for AI by being clever in your prompts. So prompt injection is one of the biggest risks. Um, Insecure output handling, to make sure if it's giving you information and it's not sanitizing the output, to make sure that there's no um, private data in it. That would be bad. That's a risk. Training data poisoning, and we're going to talk a little bit about bias in just a second. But these AI models that have been trained are only as good as the information that's been put into them, right? And so, what you may be seeing in these public models now are is training data that's been uploaded to it with the sole purpose of poisoning the well, so that it doesn't give you accurate results. Denial of service, same as a website, people hitting it so hard that it can't give you the information that you want. And then there's some more too, but I recommend you look at the OWASP top 10 for security risks. It's the definitive and ever changing top 10 list, as Casey Kasem would run them down for you. Technical pitfalls. So again, going back to that training data, there have been lots of case studies of AI failures due to biased data, because it's garbage in, garbage out, right? So historical bias, which can lead to AI perpetuating outdated biases, such as if you uploaded every resume you've ever gotten for a CEO position into AI and then said, okay, use that data to help recommend our future CEO or president, for example, let's just say. Um, all of our presidents have been men up to this point, right? So it's going to be historically biased to look at resumes and recommend a man because that's what it's always been. Um, so that's something you have to watch out for. There's also something called sample bias, in which data is skewed in a way that's driven by the methods of capturing or selecting data. So do you remember? A couple of years ago, Microsoft released a chatbot on, was it part of Bing? I think maybe this is before Copilot, and it took about a day and a half of that chatbot being unleashed before it became sort of a uh, out of control, because it people were feeding it racist data, I think, for example, and other sorts of things, and it just picked up and learned and ran with that stuff. So you got to be careful about what you're teaching it. It's like a little child. And then, of course, you have to be careful not to overcorrect as well, such as last year when there was somebody realized that, for example, there was a historical bias in one of the AI bots that was, no matter what you asked, it was almost always generating like white men in the picture. This is not an LLM. This was a one that generated images, and the developers overcorrected and tried to take into account the entire world's population and not just the training data that it had. And then you would ask it questions like, give me a picture of the founding fathers, and it would give you people of all different colors, which, the fact is they were all like white dudes, right? Um, so that's an example of overcorrecting. Measurement bias, typically used to describe faulty sensors or measurements when the measurement isn't objective. Uh, Aggregation bias, which is combining data, for example, that shouldn't be aggregated. Like when you look at your average salary in the United States, if you include outliers like professional athletes in there, it's going to skew the data higher than it really is, right? All kinds of biases. Oh, we just talked about aggregation. Confirmation bias. You see this all the time, for example, in your Spotify playlists, where it keeps recommending songs from bands that are similar to bands that you've already listened to, which is great, except you're never going to get out of your groove. You're never going to hear maybe a kind of music that you might love, but it's outside of your algorithm, right? Or you see that all the time actually on social media, where your social media feed is going to give you the kinds of things that you probably would already be likely to read, and nothing that would counter your existing beliefs, right? That's confirmation bias. So all kinds of biases that are possible with AI. One thing is, I mentioned earlier that AI seems like a black box, and as a black box, it's kind of difficult to understand how it's coming up with its answers. One thing I really like about Copilot in Edge is at the bottom, if you use Edge, do I have it up here? I don't. But everyone fire up Edge right now, open up Copilot on the side and ask it a question, and it'll give you its answer, but it'll also give you citations to where it got its answers from, which I think is fantastic. It reduces that transparency, or increases the transparency as it may be, so you know where it's coming up with its answers. And there are certain places where it's very important to know, where did you come up with that answer? Financial and healthcare, for example. Technical pitfalls. I mentioned before that AI takes a striking amount of energy to do. They are getting better at this. Now, I mentioned a little bit about what's going on behind the scenes with all the vectors. And if you can imagine the kind of mathematics that's happening behind the scenes to do the searches and the transformations and the embeddings, um, what do they call it? Linear algebra. Linear algebra is kind of where I got off the math train in college, because I couldn't understand how to like multiply matrices and such. And those were like two-dimensional matrices. When you get into multi-dimensional matrices and doing the math on those, this is why NVIDIA stock is, through the roof right now, because they've got these chips that specialize in optimizing linear or matrix multiplication and other types of math that is needed for doing this AI stuff. I don't know if you just saw last week, Microsoft announced that they're going to fire up 3 Mile Island so that they can handle the energy demands of AI. I thought that was kind of striking. So yeah, right now it's kind of crazy. And of course, there's all kinds of other costs involved, not just for energy, but for training and deploying your solutions with AI as well. One thing that people talk about a lot is, oh, is AI going to take my job? Maybe, hopefully it'll take away the worst parts of your job, the drudgery, the stuff you don't like to do. I will tell you right now that AI was crucial in developing this presentation, because it took away a lot of the. I would ask it a question and it would summarize a bunch of concepts for me and give me the notes for them. And it actually gave me the outline for the presentation in the first place, which I thought was fantastic, because that's always the hardest part, is just getting going, right? So yeah, AI might take some of your job, but hopefully it will um, take away the worst parts of your job so you can focus on the better parts. And of course, AI, as I've mentioned a few times already, always needs a human being to validate its responses. You cannot take what it's um, giving you for as truth, and that gets into the next risk, which is misinformation. You've heard about hallucinations, which is a way of saying AI just making up information. And I'll tell you, AI is kind of like a consultant in this regard. It'll make up information and it'll sound so confident that it's correct that you'll believe it. But don't. You gotta double check it. And that includes the risk right now, especially this election season, of deep fakes. You cannot take any video that you see or any audio clip and assume that it's authentic right now, because it's so easy to use AI to make a video that looks and sounds just like somebody else. Um, it's a kid can do it. And right now we're sort of at this weird crossroads where, like, there's no law saying that if I generate something with the AI, I have to label it as such. So it's up to us as humans to discern whether it's real or not. And of course, another risk is over reliance on AI, letting it do everything for you without double checking. You all heard about that lawyer that had AI generate a brief that made up case history, and the judge looked at it and said, "Dude, no." And so, another risk. There are, of course, legal, regulatory considerations to take in mind. But it's not all gloom and doom. Uh, the future of AI and software development, we're going to have more efficient models. We are going to, right now is the most energy we're ever going to use. It's gonna get more efficient, better. Um, we're going to have AI augmented creativity, um, and real opportunities for innovation. So how can you, as a developer, stay relevant? Well, this is my tips for you. Continuously be learning. And the fact that you're sitting here right now listening to me prattle on means that you've got the right mindset of keeping your, the constantly learning mindset. So go ahead and play around with those sandboxes that I mentioned. Hugging Face is a great, I put that icon on here. It's a great one for playing around with different models. Embrace AI tools and experiment with AI in your side projects. Probably not in your development quite yet, without proper, guide rails. It's also up to us to help shape the ethical use of AI, because this can go in a lot of different directions right now. And if we're not focused on making sure that it's used for the right reasons, this could all become like a dystopian future where AI is being used in all the wrong ways. And also, I mentioned we're still in narrow AI, but we are right on the precipice of something much, much bigger. This is really going to transform humanity. General AI is coming. Um, Sam Altman said within tens of months or dozens of months, so within the next 10 years probably. And then after that, super intelligent AI. And those will all be game changers. So let's summarize here. Big picture overview of AI. Hopefully you all understand a little bit better, like what's going on with vector databases, with indexes, with transformations and embedding, with RAG. Uh, and we drilled down into how AI can help you as a developer, and specifically integrate AI with your Visual Foxborough applications. I'm super eager to hear if anybody's doing anything right now with it, or what you think you might be able to do with it. Unfortunately, I don't do a lot of Foxborough programming these days, but it'd be so cool to have a project that I could use this with, a real project. And if you're out there still developing with Foxborough, this is an opportunity for you to embellish your applications with some AI. Also gave you some issues and pitfalls and other red flags to watch out for, and we talked about the future of AI. The code that I did to integrate my Azure with or my Visual Fox Pro with Azure AI Studio is in this GitHub repository right there. It's not much, and honestly, ChatGPT generated the bulk of it. I wrote the screen, yay, but it did everything else. So go ahead and I'm gonna leave that up on the screen there for now. But don't forget to Well, let's take questions first. I'm sure there's a whole queue of them now, right, Rick?
There actually is one question.
Fantastic.
Um, uh, in the context of RAG,
Yes.
if you populate it with some stuff like PDFs with invoice information, can you use RAG to pull a single
Hmm.
page result from one account from a large PDF with an account number search?
That would be the direction that I think you could use it in for sure. Although that seems within the realm of our relational databases as well. But the idea behind the question is, first of all, uploading the PDFs of the invoices. For example, your accounts payable, right? And all these invoices are coming to you on paper, I guess. So you scan them into a PDF and you upload them into your RAG. Specifically, then the question is, can you pull it from by an account number and retrieve that one? I'm not sure that that's the best solution for that particular use case, but bigger picture, can you can you derive information from those invoices that you uploaded? The answer is yes. I'm not creative enough to think of what information you would ask it exactly, but yes. One thing I will tell you too, I should have put this in the risks, is that LLMs are not great at like math. So you upload all your PDFs of your accounts payable, your bills. You can't just say, "Hey, how much do I owe? How much was I billed last month for something?" Um, because remember, they're just pattern matching. And so even though they can see the numbers, unless it's seen the the formula of exactly those numbers adding up before, it doesn't know what to generate as far as text goes for a total, because it's just not that smart yet. So it's you gotta play around, and maybe they are working on models that are optimized for math. I think that wouldn't be outside the realm of possibility, but I, it's not one thing that does very well at this point.
Okay. And then one other question, and this is maybe something for the Q&A section,
Mhm.
is as a fellow content creator, what are your thoughts on having your content that you work so hard to do over the years be automatically slurped up into the models?
Yeah, that's a great question, and there's some controversy there because I don't think we knew that that was going to happen, right? Uh, did we consent to that happening? Either we, either we, either we did and knew it, which I think is the exception. Most likely, we did consent to it, but didn't know it because it was buried in that terms and conditions that we all skipped past real quick, or we didn't consent and they never said that they were going to use it. And right there is a real ethical or maybe even a legal conundrum, because if they're using that content that we uploaded without our consent and never told us that they're going to do it, that's bad, right? How do I feel about it personally? If it were my bread and butter, I probably would be far more upset. In general, I'm happy that anything that I create is getting used for the general good. Um, and as long as nobody else is taking that content and repurposing it and saying it's theirs and then making money off of it, um, which it could be argued that that is happening, but I'm generally okay with it.
Okay. Just one last question before you go, and that is Kevin Ragsdale is specifically asking if you can paste your Azure API key into the chat.
Oh, absolutely, Kevin. Yeah, absolutely. You can use all my $200 of credit. That's a great question. Oh, and as long as we're talking about that, so when you go to my GitHub, you'll notice that my API key is kept in a .h file that is not in the repository. And I think we talked about that in a different session that I had a couple of conferences ago. Make sure, make sure you don't. And actually, I think GitHub will watch for that kind of thing now and alert you if you try to sub, uh, commit code that has secrets in it. But don't don't uh, don't put passwords and API keys and things into your repository.
Okay. I think
Okay.
we're all
Hey, look
done.
at that. It's right on time. Not bad. Thank you all. Don't forget to fill out your evaluation, and I appreciate your questions. I'll scooch over to that other session now, and if you have any more Q&A or whatever, we can chat about it.